All right, so what we want to talk about today, this, by the way, is a very long lecture. I have never gotten through this in one day. We will see how far we get today, but there is a good chance we'll have a little bit of spillover into Thursday, so don't get too panicked. There are 4 parts to this. I'm only going to cover 3 in any detail, even if we extend it to Thursday. The 4th part is something that you're going to want to look at. You're particularly going to want to look at it from the aspect of your next lab is going to be helped greatly if you spend a little bit of time looking at some of the string operations for us, converting back and forth between strings and lists. How to split lists into strings and how to recombine those lists into strings. Split strings into lists and recombine the lists back into strings that make sense. So do take a look at that. We probably won't cover it in detail in this class, but you are responsible for it. Okay. All right. So I mentioned aliasing a couple times. So let's look at a little bit of an example. And what we want to start talking about is this whole concept of aliasing and how we access lists and how we store lists. So if we start off, we're going to have this list. And L1, if we look at the type of L1 is a list. And if we look at L1 has 3 values. Now, we can come in and we can say something like, L2 equals L1. And now we can see that L1 and L2 both have the same values, right? And that's kind of like saying, A equals 7, B equals A is 7, B is 7, right? I mean, that's at least the model we're working under. And I'm going to show you why that's kind of a dangerous model to have. But for now, let's just kind of leave this. We go in here and we can say something else. We can say maybe instead of L1 equals RPI, WPI, and MIT, let's say L3. Now if we look, L1, L2, and L3 all have the same values, right? They all have lists that have the same entries in them. Let's add something. We know what the append operation does. Let's append, RIT to the end of, I don't know why we would want to append RIT, but we'll put RIT on there, right? And if we look at L2, well, that now has RPI, WPI, MIT, and RIT. And now let's go a little further, and let's say that L2 sub 1, where we have WPI, who wants to be associated with WPI? We'll put in Caltech instead. Okay, and now if we look at L2, we have RPI, Caltech, and MIT. And remember, we started out with RPI, WPI, and MIT. So here's the interesting thing. If we go through and look at it, L1 has changed. L2 has changed. Good old L3, well, that's kind of stayed the same. And this is actually being caused by this whole phenomenon called aliasing. What we want to do is, rather than try to remember what's going on here or remember certain rules, what we want to do is we want to understand what's actually going on in this specific example. So let's try something else. Let's say A equal, A is 7, B is 7, and we'll say A or B, why not, plus equals 2, and now we have B is 9, and if we're using the list model, A should also be 9, right? Because we had up here B equals A. But in fact, right, changing B does not actually change A. So let's take a quick look at what's actually going on here. I don't want to spend too much time on this particular slide, but it's probably useful to spend at least a few seconds on it. All right. So when we have A and B, what we're doing is we are having a memory location. All right, here's our memory. Okay? And memory location has specific chunks. And we kind of walked through this before. When we have a variable name, we're just saying A refers to this memory. B refers to this memory. When we say A equals 7, what we're doing is we're taking the value 7 and we're popping it into a location in memory. And when we say B equals A, what we do is we take whatever's in A and we move it down so it's in B. And that works just fine for most of our variables, most of the values that we'll store. When we start getting into things like lists, where we're storing a lot of information, that starts to break down. When we say L1 equals a list of what I have, RPI, WPI, and MIT, and I should probably make these strings, something like that. When I say L1 equals this list, what we're actually doing is we create this list out in other memory, right? Out in our heap space. And this list has a starting location at some memory location, 0x007FB6 maybe, something like that, right? This value doesn't matter, but what happens is that we create this out in memory, and then we take this 0, and by the way, 0x means hexadecimal. Value, and instead of putting the list into memory, what we do is we put the location of the list in memory. So now when we say something like L2 equals L1, just like we did with A and B, we take whatever's in L1 and we copy it down into L2. So now what happens is L1 points to this list, and L2 points to exactly the same memory. Okay, so this is not the list. This is a reference to the list. Now we come in here and we say L3. We say L3 equals, it'll be the same list. Well, this creates a new list out in memory with maybe 0x0007FBA, something like that. So this gets 0x0007FBA. Anytime we make a change with L1 or L2, we are modifying the list that exists in that memory location. Okay, so anytime we make an operation with either one of these, this is the list that gets modified. And it gets modified for everybody, right? The list starting at 7FB6 gets modified. This list, which is way off here someplace else, doesn't get modified because it's in a different memory space. And when we're talking about aliasing, that's really all we're talking about. Okay, there isn't anything else to it. It's just how memory is organized. So let's do one more thing here. Let's go to our handy dandy Python tutor. And now let's kind of walk this through. Python tutor is great because Python tutor allows us to show all this stuff. So here's what happens when we do a equals 7, right? We have a variable a in our global frame. The value 7 gets put into the memory that a refers to. So we're actually taking that memory location and we're stuffing 7 in there. When we say b equals a, the contents of a get copied into where B is, right? So that's exactly what we pointed out. And if we do B plus equals 2, all that does is go through and increment this, okay? So now let's look at our lists. We do L1 equals, right? This is the pointer value. This is the memory location of where we stuffed this list out in the rest of memory. Okay, and that's what I've been talking about. That's what I showed you on the board. This is exactly what happens. And now we say L2 equals L1. And what we do is we copy this value, not this value right here down into variable L2. Okay, and that's the aliasing. Both of these variables refer to the same part of memory. And if we come through here and we create another L3 equals RPI, WPI and MIT, this new list gets put elsewhere. So that's a completely new list, completely separate, with a completely different memory location. So all we're doing is we're actually dealing with memory locations. And I can do something, I'm not going to do all of those, but certainly we can come down and we can append, we'll just do L2 sub 1 equals Caltech. Right, and we do that. Now we've replaced this value with Caltech, where it used to be WPI. But down here, we haven't replaced it because this is a separate memory. This one affects both the variables L2 and L1. All right? And that's really all aliasing is. If we wanted, we could even say we'll do L1.append. Boy, my fingers are not working today. There we go. Right? And now we've modified L2 to get Caltech in there and L1 to get RIT in there, but it doesn't matter because they both refer to the same memory space. Okay? Whenever you get confused about aliasing, this is the important thing to remember, is exactly this diagram. This is all aliasing is. You're passing around pointers, and if you know what's being passed around, as opposed to passing around integers or etc., you kind of can figure out what's actually going on. Drawing these diagrams, I would run through Python Tutor and practice drawing these. It really does help you out, and it's the best way to actually understand what's going on in memory. Okay, let's go back to our notes. Okay, so why is aliasing there? Well, this says Python uses aliases for images, lists, tuples, strings, and as we'll see later, sets and dictionaries. I'm going to go a little further. Almost all languages use this to some extent. And in fact, if you get down and learn C and C++, what you'll find out is they don't call it an alias, they call it a pointer, and they pass it around, and it can be very confusing, and they have multiple ways of using them. But overall, all they're doing is the exact same process here. They're passing around references to memory as opposed to actual physical arrays of values. And they do this because as you get into something like an image or even lists or records from a database stored in lists, these start becoming very substantial codes of memory. So if you start copying them around, you pay a penalty both in memory usage and in in the time required to actually do the copies when you do L2 equals L1. So, it's a practical thing. If we didn't do this, our computers would be a lot slower, but it is a pain in the neck when you're trying to learn it and use it. Okay? Let's see. One thing you may notice here is we'll never talk about aliasing in terms of tuples and strings, right? But yet, when we look here, where's my cursor? There we are. When we look here, tuples and strings are actually mentioned as things where we pass around values. And we can see this in our Python tutor if we want. At least Python tutor does a bad job of displaying strings, but it displays tuples quite well. So if we have T1 is a tuple instead of a list of RPI, WPI, and MIT, right? That creates the same reference to something that's stored out in memory as a list does. And we can even do T2 equals T1. And you can see that they now both point to exactly the same place. But we're never going to talk about aliasing in terms of this because strings and tuples are immutable. So there's no way to do something like T1 sub 0 equals, or sub 1 equals Caltech. Right? That gives us an error. Tuple object does not support item assignment. And similarly, if we try to do a T1 dot append RIT, oops, let's get rid of this one because that's still causing us the error. Right? We're going to get a different error that says you can't do an append. And strings and tuples are immutable. You can't change them out from under another guy. So if you're both pointing to the same thing, the only option you have is to say something like T1 plus equals RIT, and as soon as you do that, what happens is this tuple out in memory remains unchanged. You create a new tuple as, this right-hand side, right? This is the same as T1 equals T1 plus RIT, right? So this creates a new tuple, and then we assign that tuple into T1. So the tuple that T2 is pointing to remains unchanged. All right, so this is kind of what you need to remember going through. The only reason aliasing doesn't affect tuples and strings is tuples and strings are immutable. Aliasing is just a byproduct of how lists and sets and dictionaries, etc., are passed around, how we do assignments with them, and it's because of the fact that they can be arbitrarily long and arbitrarily complicated. Okay.